In Unit 10, we will be studying trigonometry. By definition, trigonometry is the study of triangles. So we'll be going in and studying angle measure and side lengths of triangles. Before we can actually get into all of the information on trig, we have to make sure that you understand some of the basic details. In question number 1, they are asking for us to label in the picture the opposite, adjacent, and hypotenuse sides of the right triangle. In part A, they are asking us to do that with respect to angle A. So angle A is the angle that I am going to be focusing my attention on. With respect to angle A, the side that goes across from it is considered the side opposite. The side that's next to it is considered the adjacent. And I know some of you are probably saying, well, there's two sides next to angle A, but remember, across from the right angle is always the hypotenuse, so this side is going to be the hypotenuse. So yes, there are two adjacent sides, but one of the sides already has a very special name called the hypotenuse. In part B, we're also asked to name those sides, and this time it's with respect to angle C, so I want to make sure that I'm focusing my attention on angle C. The side opposite is the one across from it. The adjacent is the one next to it, not the hypotenuse, and of course the hypotenuse is the side that's across from the right angle. So when we're working on problems with trig, one of the things that we have to make sure that you understand is what the trig ratio's definitions are. So we'll be talking about sine, cosine, and tangent, and this is the triangle that we're going to be using here with angle theta. So theta is a symbol that is used as a variable for an angle. So instead of putting x in the angle, oftentimes they'll use theta. There's two other variables that you may see. One of them is alpha, and one of them is beta. So don't be surprised if those show up throughout the rest of the unit. So with respect to the sine of angle theta, by definition, sine is the side opposite over the hypotenuse. So if I take a look at my picture, with respect to angle theta, this is my opposite side, and this is the hypotenuse across from the right angle. This side is the adjacent. So in this, if I was going to label my triangle, let's call it RST, and I was going to put those side names in to the ratio for sine, the side opposite would be RS over the hypotenuse RT. And then we're going to go back and do the same thing now with cosine. By definition, cosine is adjacent over hypotenuse. The adjacent side is ST over the hypotenuse RT. The tangent of the angle, by definition, is opposite over adjacent. And if I fill in that information, the opposite side RS over the adjacent side ST. So those are our trig ratios. Your job is to know what the definition of each of them are. In here, we do have a mnemonic device that we do use to help us remember that, and the mnemonic device is called SOHCAHTOA. The S stands for sine, the C for cosine, the T for tangent, and the next two letters that you see there are the letters that represent the ratio. Opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. So a lot of times you will see me referencing back to the SOHCAHTOA mnemonic device to help us remember which of the ratios goes with which of the trig ratios. One last thing that I do have to note here is that triangles must have a right angle in order to use any of the above, the sine, the cosine, or tangent. When we get towards the end of this unit, we will be talking about how to solve in triangles when there's not a right angle, but for right now, everything that you do has to have a right angle in the triangle. When you go on and take a look at question number 2, in question number 2, there's a triangle that's drawn for us. It does have an X, a Y, and a Z in there. that we technically at this point in time don't know the values of. If we take a look at the triangle separately, with respect to the angles, we can see that we have a 90-degree angle, a 30-degree angle, so this y angle that's up here, we know is going to be 60. The angles in the triangle have to add up to 180. So that being said, in my 6 problems that I'm going to do with respect to this triangle, 3 of them have y's in there, and I'm going to go in and turn those y's into 60s, just to make my life a little bit easier. So while we're here and we're talking about that 60-degree angle, the directions tell us that we are supposed to express the trig ratio as a fraction. With respect to the green angle of 60 degrees, x is the side opposite, 9.2 is the side that's adjacent, and z is the hypotenuse. So if I look at part B, cosine of 60, I know that cosine is adjacent over hypotenuse, which is going to be 9.2 over over z. If I go on and look at part D, another one that involves the 60-degree angle, this is sine, which I know is opposite over hypotenuse. So this will be x over z. At this point, we don't know the values for x and z, but we're going to talk about those. And then part F is the tangent of 60 degrees, which is opposite over adjacent, which gives us x over 9.2. If I change my focus now and I go back and look at the 30-degree angle, the names of my sides change. So with respect to this 30-degree angle, now my opposite side is over here, my adjacent side is here, but the hypotenuse still stays the same. The hypotenuse is still across from the right angle. So with respect to that 30-degree angle in part A, the sine is opposite over hypotenuse, which is going to be 9.2 over z. Part C, the tangent, is opposite over adjacent, which is 9.2 over x. And then part E, the cosine of 30, adjacent over hypotenuse, which is x over z. For part G to this question, they are asking for me to find the values of x and z using the rules for special right triangles. Some of you may have noticed when you started this question that that triangle that they're giving us is a special right triangle. In the special right triangle, it has a 90-degree angle, a 30, and a 60. 9.2 is over here. That's the A side that's across from the 30. The 2A side that's across from the 90 is labeled as Z. And then the side across from the 60, which is the A radical 3 side, is labeled as X. So in this case, I can go back now and I can fill in the values for X and Z. So in here, if my A is 9.2, then for the Z side of 2A, I'm going to get 18.4, 2 times 9.2. And for the X side, I am going to get 9.2 radical 3. The question is asking me to take the values of X and Z and go back and put them into parts A through F. It's then asking me to use my calculator and see if the sine of 30 in part A is really equal to 9.2 divided by our new Z value of 18.4. So our calculator is supposed to go in and tell us that this value equals this value. So we already know that the 9.2 over 18.4 is going to give us 1/2 or 0.5. We need to type into our calculator what the sine of 30 is. You need to make sure that your calculator is in the correct mode. So if you hit the mode button on your calculator and you get to the third line down under that menu, you're going to see radian degree. you need to make sure that your calculator is set in degree mode. It's got to be the highlighted one before you type in the sine of 30. So right now, you don't know anything at all about radians, so it doesn't make any sense for you to have your calculator in that mode. So once you have your calculator in the correct mode, use your calculator, type in the sine of 30, and you're going to find out that that is 0.5. So they're asking to show that the sine of 30 is equal to 9.2 over 18.4. So in a sense, they're asking you to prove that when you use the relationship that you know about a 30, 60, 90 right triangle, that it really does come up to be the sine of 30, which is opposite over hypotenuse. I'm not going to go through and do all of these with you, but I will pick a couple to do as we go through this. Let's take a look at part C. C is talking about the tangent of 30. And if I substitute in, I get 9.2. Over my x value, which we calculated is 9.2 radical 3. Technically here, this is the same as 1 over radical 3. And if we were going through and doing this, we know we can't leave it as 1 over radical 3 as our final answer. But the only thing that we're doing here is typing these things into our calculator. So on my calculator, when I type in tangent of 30, and I type in 1 divided by the square root of 3, in either case, I end up with a decimal value, and I'm approximating here, of 0.5770. And that is the same thing that I get when I type in 1 divided by radical 3. So I'll pick one more to do here. I'm going to do E, cosine of 30. So in this case, I'm supposed to show on my calculator that the cosine of 30 is equal to my x value of my 9.2 radical 3 over my z value of 18. Some of you may wish to, 18.4. Some of you may wish to reduce this and turn this into radical 3 over 2, which is fine. So I'm basically checking to see that cosine of 30 is the same thing as radical 3 over 2. So when I type in the cosine of 30, I end up with, and I'm rounding here, 0.8660, which is the same thing that I get when I type in radical 3 over 2. You need to be careful on your calculator when you type that in, because if this is your calculator screen, when you type in radical 3, sometimes it starts a set of parentheses for you. You need to make sure that you're closing them, because the only thing we're taking the square root of is 3 before you divide by 2. So if those parentheses appear, please make sure that you go back and close them to indicate that your square root only goes to there, and then you're dividing by 2. As we go on and look at a couple of examples on how we use trig, you can see in question number 3 that they're asking us to find the y and the z, and they're asking for us to find them to 1 decimal place. So in here, the angle that is being referenced is this 28-degree angle. And with respect to that 28-degree angle, I have the side opposite, the side adjacent, and the side that's the hypotenuse. So if I'm working with this side of y, and I'm solving for y, it's the opposite, and I'm going to link that up with the adjacent. So based on the SOHCAHTOA that we talked about previously, if I know that I'm going to be using the y and the 22.5, the opposite and the adjacent, that to me tells me that I'm going to be using tangent. So the tangent of theta equals opposite over adjacent. Remember, theta is the angle measure. So if I go through and do the work for this now and substitute in what I know, I'm putting in tangent of 28 for the angle, opposite of y, adjacent of 22.5. I would not pick to do the opposite and hypotenuse together because at this point in time, that would mean that I would have two unknowns in my ratio, and I don't want that to happen. When I go through and solve here, it's a proportion. I'm going to cross multiply. Tangent of 28, you need to make sure that you keep together. It's one number. So when I cross multiply, I am getting 22.5 times the tangent of 28. And when I type that 22.5 tangent 28 on my calculator, you can type the whole thing in. I end up with y equals 11.963462221, which when I go through and round that to one decimal place, turns out to be 12.0. The Regents regulations require that you show your ugly decimal, the big yucky number, before you round. In other words, we need to see what you are rounding from to get your 12.0. If I go through now and I want to find z, when I'm working with z, I know that z is the hypotenuse, and I'm going to link that back also to the 22.5. So I'm using adjacent and hypotenuse, which tells me that it's cosine. My formula for cosine is cosine of the angle theta equals adjacent over hypotenuse. I'm going to plug in what I know. In this case, same thing happens. I need to make sure that I keep this together. That is a number. Put this over 1, cross multiply. So I have z times the cosine of 28 equals 22.5. I'm going to divide both sides by the cosine of 28. Remember, that's just a number. So this is 22.5 divided by the cosine of 28. So I'm typing that into my calculator just like I see it. 22.5 divided by the cosine of 28, which gives me 25.482,82614, and to one decimal point, 25.5 for my final answer on that one. For question B, we have the same scenario here where we have two variables that we're solving for. We're going to solve for those separately. So in this particular case, the angle that's being referenced is this angle of 53 degrees. This is my side opposite. This is my hypotenuse. This is the adjacent. If I'm working with x first, to find x, that's the adjacent side, and I have to link that up with the hypotenuse because the hypotenuse is a known value. So adjacent and hypotenuse is going to be cosine. So this is cosine of angle theta equals adjacent over hypotenuse. I plug in what I know. Cross multiply. Type in 7 cosine 53. I end up with a value of 4.212705162. That's my unrounded ugly number that I then have to go back and round to one decimal place or the nearest tenth. To find y, I need to deal with that opposite side of y and the hypotenuse. Opposite and hypotenuse is sine. So sine of theta, opposite over hypotenuse. I'm going to plug in what I know. So sine 53 equals y over 7. I'm going to cross multiply, so I will end up with y equals 7 sine 53. Type that into my calculator. I get 5.59044,857, and to the nearest tenth, that gives me 5.6 for my final answer on that one. When we turn the page, we are also asked to work with the triangle that's given. In the triangle that you see here, we have all three sides given in this particular case. We are going to be asked to find the measure of angle D. So in this case, if we're talking about angle D, this is the opposite, this is the adjacent, and this is the hypotenuse. If I'm looking for angle D in terms of sine, I would say that the sine of angle D is equal to opposite over hypotenuse. So sine D is equal to 4 over 7. And my job is to find angle D. In order to find angle D, I have to get the word sine away from it. So I'm technically going to inverse sine on both sides. So I'm basically doing inverse sine on both sides, which means that it cancels out over here and appears on the other side of 4/7. On your calculator, if you're looking for angle D, you would type in second sine 4 divided by 7. So in this case, D would be equal to 34.8499. And again, I'm rounding that. You shouldn't round unless they tell you to, but on this, we're more worried about you learning what you're doing versus what you're rounding to. For with the part with the cosine of angle D, I'm kind of doing the same thing. The cosine of angle D, we know, is adjacent over hypotenuse. So cosine of D equals radical 33 over 7. I have to solve for D. The way I get D alone is I cosine inverse both sides, which causes the cosine on the left to cancel out, but it does appear as an inverse on the right. And I am typing in on my calculator second cosine radical 33, close your parentheses if you need to, divided by 7. And I end up with D being 34.8499. Again, I'm rounding that. What they want you to notice here is that it doesn't matter if you solve for D in terms of sine or cosine, you get the same answer. If I do that same thing in terms of tangent, the tangent of D is equal to 4 over radical 33, opposite over adjacent. D, therefore, is equal to tan inverse, 4 divided by radical 33. And guess what I get when I go through and do that? Second tan, 4 divided by the square root of 33, 34.8499. So whichever one you use to solve, it's not going to change the value of the angle measure. It's going to remain the same no matter what. You could also go through and do the same thing with angle E. So this would be your opposite, your adjacent, and this is still your hypotenuse. I'm not going to do that with you, but if you'd like to practice that on your own, make sure you know how to use your calculator to find the angle measures, then go ahead and do so. In question number 5, they are asking us to find the angle measure for angle B, and it's to the nearest tenth. So in here, all three sides are not given to us. So I'm going to go in and say, okay, well, what exactly did they give me? So if this is angle B that we're focusing our attention on, this is the opposite and this is the hypotenuse. So going back to SOHCAHTOA, in this particular case, I'm going to do the sine of theta, opposite over hypotenuse, plug in what I know, angle B, opposite 7.2 over hypotenuse 15.43. I'm in charge of solving for angle B, so that means that I am technically doing sine inverse on both sides. causing these to cancel, and I end up with B equals sine inverse 7.2 over 15.43. So on this one, I wrote that I was kind of sine inversing both sides. You don't need to write that. It's kind of when you move the sign to the other side, it's going to present with that sine inverse that's there. Type this in on my calculator. So second sine, 7.2 divided by 15.43. And I have B is equal to 27.81534034, which means B, when rounded to the nearest tenth, is 27.8. I'm going to skip part B, where you're actually solving for angle C. I'm not going to do all the work, but I will set that up for you. This is adjacent and hypotenuse. So when you go through and do this, you should be doing the cosine of C equals 7.2 over 15.43. And then you can go through and figure out what your answer is for that. For question number 6, I'm not going to do all of these as far as finding angle alpha. Remember, this is an alpha and beta. But I will talk about one of them briefly for you. Let's suppose that we're talking about beta, and we're looking to figure out how big beta is. In this case, we do know all the angle measures, so you can pick to work with whatever you want to. So if I am looking for angle beta, let's just suppose that I'm going to do, I'll do opposite and hypotenuse. So I'm going to do sine, and you could pick any of them. So this is 3 radical 3 over 9. So which means beta, when I go through and do this, is sine inverse 3 radical 3 over 9. Type that in on my calculator. Second sine, 3 radical 3, close your parentheses, divided by 9. And I find out that beta here is equal to 35.26438.968. To the nearest degree, remember this is an angle measure, so 35 degrees is what this will round to. For question number 7, Common Core question here, right out of the Common Core binder, it's talking about you having 3 city streets that intersect to form a right angle. So I'm going to draw my 3 city streets here. Here's the right angle. It says Main and State are the ones that are perpendicular. So Main and State. Laura and State Street intersect at a 50-degree angle. The distance along Laura Street to Main is 0.8 miles. If Laura Street is closed between Main and State Street for a festival, how far to the nearest 10th will someone have to travel to get around the festival if they only take Main and State? So our question is essentially asking us, if this is the normal route somebody takes, and it's 0.8 of a mile, and that road is closed, and they still need to get from point A to point B, and they have to take the long route, which goes this way, how far will they have to travel? So that means I'm basically in charge of finding this value and this value. I'm calling them X and Y. You can call them whatever you want to. So I essentially, with respect to angle B, I have a hypotenuse here, an opposite here, and an adjacent here. I'm going to do the sine of the 50-degree angle to involve the x, which is x over 0.8, and I'm going to do the cosine of the 50-degree angle, which is going to be the adjacent of y over 0.8. And then to solve from here, I'm going to go back and type these into my calculator. So 0.8 sine 50 which gives me 0.612835554, and that's of a mile. And then I do 0.8 cosine 50, which gives me that y is equal 0.5 0.514, actually that's wrong, 0.514, 230088. I have to add the x and y together to find out the long way around, the long distance. Which gives me a total of 1.127065642. This question is asking me to round in miles to the nearest 10. So when I round this to the nearest tenth, I get 1.1, 1 1/10 of a mile. Sometimes the questions you do are going to be very obvious that they are indeed trig questions. Sometimes you might have to go ahead and draw the picture to figure out what it is that's going on.